Hello and welcome to this lecture about the basics of distributed version control. This is the first section of the course Introduction to DevOps. So, in today's lecture we will cover three different topics. First of all, we will discuss the fundamentals of version control systems. Then I will present three different types of version control systems and their characteristics. Finally, the focus will be on Git, which is a common and very popular distributed version control system. So, let's start with the fundamentals of version control. First of all, what is version control? Well, it is a technique to keep track of changes in a file or a set of files, as it commonly is the case. Version control system essentially records and saves the different versions of the software, and especially the files are in the center of these solutions. So the version control system will keep track of the files and save the information about how the files have changed over time. Now, in the context of software engineering, it is very useful to have this kind of a system, as the files will evolve and change over time, especially when we are talking about a long time span like 6 months or a year. The files can have very significant changes, and it is very useful to have this kind of a system that will record the changes that have been made over time. And the key thing about version control systems is the ability to jump between the different versions. So, for example, if the latest version of the software includes a bug or some kind of an error in the software, we don't have to immediately go ahead and try to find it and fix it. We can just revert back to the latest working version of the software and worry about the bug and an error later in a better time. Generally speaking, there are three types of version control systems. First of all, there is local version control. And as the name says, it only works locally on a single machine. The version database is stored on the machine itself. So, for example, if I was to use the local version control, I would install a software like RCS to my computer and then use it as the version control system. Now, if there was another developer with another machine, he or she wouldn't have access to my version history. Then there is the centralized version control. Now, this differences a lot from the local one. It includes a central server that holds the version information. And this server, servers usually can be accessed by multiple people. So this basically allows for better collaboration. So if there was another developer in addition to me, even 10 different developers, they all would have access to this remote server that has the version history of the software. Now, even though this is a significant advancement from the local version control, there still is downsides to it, and mostly because the remote server, it's a single server that can possibly go down at some point in time, and then that would mean that nobody will have access to the version history. So even though this is a better solution in terms of collaboration compared to the local version control, this isn't the perfect solution either. Finally, there is the distributed version control. Now, this is the most advanced type, we can say. And the idea is that there is the remote repository as in the centralized version control system, but in addition to that, each of the machines or the developers, they have a mirror of the whole version history. So there is a remote server that has the version history, but in addition to that, all of the clients, which means the developers or the developer's machine to be precise, they will also have the copy of the version history. So this removes the downside of the centralized version control system. Now, if the remote server dies, disconnects, it means that the version history is, well, it's unreachable to you can't reach the server to access the version history, but you still have the local history that has been synced with the remote server at some point in time. And of course, in order for this to work, it is important to synchronize the version history periodically. So it isn't much of a help if the synchronization has been done 2 months ago and the version history has been changed significantly. So the idea and the general workflow is that the synchronization between the clients and the remote server is done well, preferably even daily, or how many times it can be found suitable, but this is the core idea of the distributed version control. And well, Subversion or RCS is an example of a local version control system. Subversion is an example of centralized version control system, and Git is an example of a distributed version control system. Here is a visual illustration of the 3 different types of version control systems. On the left, there is the local version control system, which has the local version database, which is on the computer, on the local computer, whoever is using the system. So for example, if I were to use this version control system, I would have the version database of the software on my personal computer, and it wouldn't be accessible by anyone else. So this type of a version control system is only suitable for work that is done independently. No collaboration is possible with local version control systems. In the middle, we have the centralized version control system, and as I mentioned, there is the central server that has the version database of the software. So now there is the collaboration factor available. Multiple developers can access the version database and use the version control system. Now there is still the downside of a single point of failure. So if this server was to go down, then no one is able to get the version information, and until the server hopefully can get restored. But finally, we have the distributed version control. Now here we can see that all of the clients also have the version database in addition to the server computer here. So now, in case the server computer goes down, the client still can utilize their local version database and the work can continue as usual. And now the requirement, of course, is that the synchronization is done periodically between the clients and the server, so that the clients will have an up-to-date information about the versions of the software. Okay, let's now talk about Git, which is a very common and a popular version control system. First of all, it is a distributed version control system that was born in 2005, so it has been used for well over a decade now. It's a, well, like I said, very common tool nowadays in the software business. Now first important thing about Git is that it stores snapshots, not exact differences of the files. So you can think about it like in a way that Git basically takes a picture from the whole project repository from all of the files that it is watching and then saves a reference to it. Additionally, nearly every operation of Git is local, meaning that no internet connection is necessarily needed when using it. Only the synchronization between the online repository and the local repositories needs to be done with an internet connection, but pretty much everything else, every common operation is local in Git. The next point is integrity, which means that it's almost impossible, or it is impossible to change the contents of a file without Git noticing it. Now this brings some sort of safety to the developers' work, as they can rely on Git watching the files and seeing all the and saving all the changes that have been made to it. So when you are using Git, you can be sure that it can save the version differences between or over the development lifecycle. Now there is ways to hide files from Git, which we will talk about later in this course, or they probably will come up later. But in principle, if you want Git to watch a file, then it will watch it in a way that it's impossible to change the file without Git noticing it. Lastly, Git generally only adds data. Most of the operations that are done with Git are sort of additional operations in regards of data. So this has a big benefit when considering the undoing and aborting changes. Since the almost all operations are adding data, the undo operation is to remove the data that was added. Now, if you consider the opposite, if Git was to remove some data, the undo operation would be to add the removed data back, which would require some kind of backup solutions or something like that. So that isn't the case, and this means that Git is very forgiving tool in the sense that most of the operations can be undone. Now, when we consider the files that the Git is watching, they are generally in 3 different states. The files can be in 3 different states. First of all, there is the modified state, which means that Git has noticed that the file is changed, but the change is not committed yet to the version database. So it is in a state that the Git notices that there is a change, but the developer or the user hasn't decided yet to so-called stage the change or commit it. The next state is the staged state, which means that the file is modified and also marked by the user to be committed. So this means that when the user decides to update the version of the software, the staged file will be part of the update. And generally speaking, when the user stages a file, there isn't an intention to modify it further in the sense of the next commit, or the future changes will happen after the file has been committed generally. The last state is the committed state, which means that the version of the software is updated and the staged file are committed, as it is said. So committed files means that the changes of the files have been recorded to the version database. And then there is the whole project. If we consider the whole software project that Git is watching and the Git is being used as the version control system, there are 3 different sections. First of all, there is the working tree, which can be seen as a single checkout of the certain version of the project, and this means that there is the multiple versions in the version database of the software, and the working tree is at the point of some of those versions, one of the versions. Then there is the staging area, which basically is Git's way of saving information about the next commit. So the files to be committed are in the staging area. So it is a part of the project which contains the information about the files that are to be included in the next commit. Finally, there is the Git directory. This is a special directory that Git creates to the project repository, and this includes the metadata and the version database of the project, the local version database. Also some configuration files are there. This is basically where Git lives inside a project. It is a hidden directory. And all of these things will come more clear once we get to the practical demonstration part of this topic. Okay, now here we can see the basic high-level workflow when using the Git version control system. So first of all, the user will modify the files in the working tree. It can be one file or multiple files, even all of the files in the project repository. And after the files are changed, then they are staged. So essentially the user will decide which of the changes he or she wants to have in the next commit. It can be all of the changed files or some subset of the changed files. Finally, a commit is made, and this is a way to tell to Git to tell Git to record the state of the project essentially. And as mentioned before, Git will save the whole project as a snapshot, or take a kind of a snapshot from the whole project repository. So this is the high-level workflow of using Git. Now, when we think about the files of the project, there are generally two states, two high-level states that the files can be in. The states are tracked or untracked. Now, tracked files are files that were in the last snapshot. They are essentially files that the Git is constantly watching. Now, tracked files can further be categorized to three different categories: unmodified, modified, and staged. Now, unmodified files are files that have not been changed during the latest updates from the last commit or the last version. So the file has not changed since the last commit, essentially. The modified state the file has been changed but not yet staged. So Git has noticed that the file has been changed, but the change has not been staged yet. Now, in the staged state, the file has been staged for the next commit. So staged files are the files that will be recorded when the commit is made by the user. And the second high-level state was the untracked files. And now these are files that Git is not aware of. And if you remember from the previous slide earlier in this lecture, Git essentially, all of the files that Git is aware of are being watched by Git, but there is a way to kinda hide a file from Git, and this can be done with a special file called gitignore. And there you can add files or even directories that the Git won't be able to see and watch. And now this can be useful if the project repository contains files that don't want to be versioned. Okay, now here is a list of some useful Git commands that can be used. I will not go through all of them. They are here just to kind of give you a first look as to what kind of commands can be used with Git. These commands will come handy when using it in practice, and also the demonstration videos during this course will show how to use these commands. Okay, let's talk about committing next. So committing essentially means to save the changes that the user has made to the files. As mentioned previously, the staged files will be part of the commit. So the modified files, not all of the modified files are necessary part of the commit, only the staged files. And when a commit is made, Git will store a commit object that is essentially a pointer to the snapshot of the staged content related to that commit. And as I mentioned, only the staged changes will be added to the commit. And also it is good to know that if you stage a file and then further edit it, Git won't automatically add the further edits to the commit without the user staging the file again. This will all be more clear once the visual demonstration is to be held. Now, when committing, it is possible to leave a commit message, and it is recommended to leave one that briefly will state to the user, him or herself, and also the other users of the version control systems about the changes that have been made in that particular commit. So for example, if a user has fixed some kind of a typing mistake in the application, the commit message can be like fixed a typo in the front page, as you can see from the slide. Now every commit in Git has an unique ID, and this makes it possible to go back to that commit by checking out to it. So essentially go back between the different commits, so the different versions of the software essentially. Branching is one of the most essential features of Git and one of the most powerful features. And branching means to diverge from the main line of development in the version control system. So let's consider a situation that there is a main branch that the developers are using. That is that branch's purpose is to be the kind of the default branch that the software development is made. But now it is very useful to have also other branches than the main branch. For example, in a situation where a new big feature is to be developed to the software, it is good to have a whole separate branch for the feature, so that the main line of development isn't distracted until the whole feature is done. So essentially, branching is a way to change and record changes safely without affecting the main version history and the main branch. And well, branching is done very efficiently in Git. It's very lightweight operation, doesn't take much resources, so therefore it is very encouraged to be used a lot. And what a branch essentially is in Git, it's a movable pointer to a certain commit. There is a special head pointer that is keeping track of the branch that the user currently is in. And a new branch can be created with this git branch command. And it will create a branch which will point to the current commit that the user is on. And as I said, there is always a default branch in the project repository, so there has to be one branch at least where the development is made. And now when the user or the users of the version control system have created multiple branches, then this command git checkout can be used to move between the branches. What this technically does, it moves the head pointer from one branch to the another. Now here is a visual illustration about branching. So as you can see on the image on the left, the head pointer that is pointing to the current branch is pointing to this master branch, which is often the master term is often being used for the main line of development. So now there is master branch and a testing branch, and head is currently pointing at master, so that is the branch that is currently the user is currently in that branch. But now if the user runs command git checkout testing, then the head will move to point to the testing branch. So now the user is on the testing branch and can make, for example, some kind of testing related changes to the files without affecting the main line of development, that is the master branch in this case. Okay, now at some point the branches usually are wanted to be joined back to the main line of development, and this operation is called merging. So the branching would not be beneficial unless the diverged versions or the branches cannot be merged together. So this merge operation is essentially joining two or even more development histories together. And as I said, the most common usage of merging is to join a certain single branch, like the testing branch from the previous image, to the main branch of development. That was the master branch. And well, basic merging is done with the merge command, so git merge, and then the branch name is the command to be used, and it should be used in the branch where the changes are to be merged. So for example, if we want to merge the testing branch into master, then we will run the git merge command in the master branch, and the command will be git merge testing. Now it is important to notice that the merging process, it can be different based on the conditions of the development histories that are to be joined. Well, let's consider a situation where the main branch hasn't been updated with commits since the branch A, or the testing branch, whatever you want to call it, was originally created from the main branch. So if the main branch hasn't been changed, then the merge operation can be so-called fast forwarded, and Git can basically do it right away without the user needing to do any manual operations. Now if the fast forwarding isn't possible, so in other words, if the main branch has also been updated since the new branch was created from it, then it is possible that there is a need for the manual resolving. But Git is a smart system, and if it notices that the development histories can be automatically joined together, then it will do it. But sometimes it cannot be done. So for example, if the same file has been updated in both of the branches, let's say there is a README file in the project repository which has been changed in both the main branch and the new branch that was created. So this creates a situation that Git doesn't know which one of the files is the one that the user will want to have after the merge operation. And in this case, a merge conflict will happen, and Git will notify the user that he or she will have to manually tell Git which way the file should look after the merge. Now the merge conflicts can be resolved manually by the user either using some kind of a graphical tool or a command line interface. And after the conflict has been resolved, then there is a special merge commit that is made, and it basically shows how the merge operation was done. Now here is a visual illustration of the merging process. So these C0, C1, C2, they are commits of the version history, and now as you can see there is the master branch, and then there is a ISS 53 branch. It's issue 53, so in this case the branch naming has been done based on a sort of an identification code from a project management software. So let's say that there is two branches, or we can say that there are two branches, the master branch and the issue 53. And now the issue 53 branch has been originally created from the commit C2 of the main line of development. And then there has been two commits made, C3, C5, but also the master or the main branch has been updated with a commit C4. And now when the development histories of these two branches want to be merged, there needs to be a special merge commit to be made. So here is a C6 commit that has been made to merge the development histories together. Now if there was changes if a certain file, let's say a readme file, has been changed in both the master and the issue 53 branch, then the user would have to be manually, then there will be a merge conflict that has to be manually resolved by the user. But either way the merge commit will happen, and possibly the user needs to manually also resolve conflicts if that is the case. So let's now talk about the benefits of branching. I briefly mentioned them before, but one of the most significant benefits is that each developer can develop using their own separate branches, and finally then merge the changes into the main branch. So for example, if the work is divided in a way that developer A is working on feature 1 and developer B is working on feature 2 and so on, they all can make their separate branches and update the separate branches without the main branch being affected at all. So this essentially keeps the main branch clean. And then when the features have been done completely, then the histories can be joined together, and essentially the feature branches will be merged into the main branch. Now that is especially beneficial when there are multiple developers, but even in the case of one developer, branching can be beneficial. For example, if the single developer wants to make multiple features at the same time, he or she can use separate branches to that and so on. But also there are maybe some situations where a new branch isn't necessarily needed. Even though it is a lightweight operation, maybe it shouldn't be used in all of the situations. For example, if there is a very minor hotfix like changing one line of one file, then it can be done directly to the main branch, or maybe it is more efficient to at least do to the main branch. But the branching as a whole, it can be said that it is very efficient. So in the cases of, for example, feature development, the usage of branching is recommended. Let's next talk about Git workflows. So the high-level workflow that was contained the three different stages. was already presented in this lecture, but now let's talk about more briefly about a couple of different workflows. First of all, what are these workflows? They are a way of using Git according to certain guidelines. The idea is to keep the version control well structured and consistent. In order for a certain workflow to work correctly, it requires the participation of every developer, in other words, every user of the version control system. And now, when selecting the workflow to be used, the experience and amount of the developers should be considered, and also the ability to undo mistakes and errors in the workflow. So the more complicated the workflow is, the more experience would be needed from the developers, and also the more complicated it is, it can be harder to undo mistakes, at least in a clean way. And in the context of this course, two different workflows are presented, the feature branch workflow and the Git flow workflow. Now, the feature branch workflow is one that I briefly even mentioned on the previous slides. The core idea is that all features of the software is to be done to dedicated branches instead of the main line of development or the main branch. There can be multiple or a single developer working on a feature or on a branch, but the core idea is that all of the features are done to their own branches. Well, since the feature development is done to branches, that should mean that the main branch is containing a working version of the software, since the big modifications are done to separate branches. This is very important in the context of CI/CD pipelines that are a topic later on this course. So it is very important to notice that the workflows should in practice mean that the main line of development, the main branch, should contain working code or working software. And now special requests can be used in order to review the features, the feature branches before merging them into the main branch. So different version control services like GitHub has pull requests and GitLab has merge requests. So the naming of these requests differ a little bit, but most of the major version control remote repository services like GitHub will have this kind of feature to have these special requests. And in this workflow, the idea is that the feature branches are created from the latest state of the main branch. And also a structured naming can be used to create the branches. For example, the picture in the earlier slide had the ISS 53, issue 53. It can be any kind of a ID, something that can be identified by the project team, or they can be so the branches can be associated with, for example, different features in a project tracking software. The idea is that the branch naming is done in a consistent and structured way. The second workflow we are going to talk about is a Git flow workflow. And Git flow workflow extends the feature branch workflow that was discussed earlier. The core idea of the Git flow workflow is to provide a structured way to organize the version control in order to help implement DevOps practices like continuous integration or continuous delivery that are an essential part of this course later on. This Git flow workflow defines a very strict branching model. The feature branches do exist in this workflow as well, But there are also other branches dedicated to, for example, preparing, maintaining and recording releases. Now in this workflow, main branch is used for storing official releases of the software. And then there is a develop branch that is used to create feature branches and merge the feature branches back into the develop. So the core idea is that the feature branches do not interact with the main branch of the software that is dedicated only to the storing official releases. And now when the develop branch has enough new features, a new release branch will be created from it. And after this release branch is created, no new features are added to it anymore. Only bug fixes, document generation, etc. can be added to the release branch. And when the release branch is ready, so when these document generations and other release-related updates have been made, it can be merged back to master or will be merged back to master. And now the usage of this release branch allows for one development team to focus on polishing the release, while another teams can focus on even working on features to the next release. So this workflow is well facilitated to a big amount of developers, big development software development companies where there are teams that can be dedicated to separate assignments related to the software. And now if an issue in the main branch is found, a hotfix branch is created. And now the fix will be made to the hotfix branch, and then it will be merged to both the main and the develop branch. And as you can see, this Git flow workflow will add some extra rules compared to the feature branch workflow. But these changes are good in the sense of DevOps, and especially when there is a lot of development resources, multiple software development teams available. This workflow is really good to be, is really beneficial to be used. Right, here you can see the references that were used in this slide set. That wraps up this part of the course lectures. So thank you for your time, and don't hesitate to contact the course teachers in case of questions. Thanks.